Hi, this video is going to be a little bit different. We're still looking at yet another motor, but I want to just experiment a little bit now, trying different start capacitors. So this motor, incidentally, a little bit of background, the motor just came from a used wood turning lathe. The lathe wasn't really worth messing around with, but the lathe, including the motor, only cost me £5. So I snapped it up. I thought, well, I can use that. It's a single phase capacitor start induction motor. So here we go. It's that type of motor. So you can see there are two windings, a main winding and a start winding, and in series with the start winding there's a capacitor and a centrifugal switch. When we hear the motor run, or rather when we hear the motor slow down, you'll actually hear that centrifugal switch click. My question when I bought this motor was, obviously just, is it safe first of all? So gave it a quick visual inspection, insulation test, and also I popped off the capacitor, and I was a little bit surprised to see this is the original capacitor that came with it. So motor starting capacitor, that looks good, but then it says working voltage 125 volts AC. Now we're on 240 volts AC, that's RMS. So if you actually want to know the peak voltage, that would be square root 2 times that, so about 1.4 times that voltage. So we're considerably over, or perhaps we're considerably over what this capacitor should be, or at least that was my initial thought. So wasn't really too sure about this because in truth I hadn't really given it a great deal of thought before. But this motor is rated, as you can see on the plate there, 240 volts. And this capacitor which came with it, obviously I've no idea whether this is the original capacitor, but it concerned me a little bit as to whether that would be the correct capacitor. So I happen to have a couple of other capacitors. Now these are pretty large capacitors. Let me just put my hand by the side for scale. Okay, so in fact, let me just show you that's the one that it came with, and then that's one of my stock. Okay, I've got another one. This is a 30 microfarad capacitor, which is a little bit smaller. It's somewhere in between, physically in between the size of these. Now these ones are actually 450 volt AC rated, so considerably higher. That's 450 volts RMS. So you can multiply that up by 1.4 times, so 600 and something volts. And so my question really is, do I need something that is 450 volts rated, or can I get away with something like this? So what I've done is, now the mains is off at the moment, I have just taken extensions from the wires which would normally go to the capacitor. The motor starting capacitor is normally just fitted on the side there. There's like a little case that goes around it as well, and I've just extended those wires out, so just to make it convenient. So I've put this physically much larger capacitor. Remember, it's still got this same capacitance, 100 microfarads, which let me just remind you. Whoop, let's put it up the right way. So 100 microfarads. It says MFD, but they're talking micro, not milli. So it's got the same capacitance, but it's got a much larger voltage rating. So I'm assuming that this one should be perfectly fine. And then in parallel, obviously, because I'm going to take a voltage reading, I'm measuring the voltage across that capacitor. So I'm putting the meter across that capacitor there. So when the spindle is stationary, when the rotor is stationary, that switch is going to be closed. So then when you turn on the input power, you're going to have a current flow through the main winding, and you'll have a current flow through the start winding. And because of the capacitor, you're going to do something to the phase, and then it's going to start the rotor in a predictable direction. And then as it spins up to speed, then the centrifugal switch is then going to open, and then you'll only have the main winding running. So when it gets up to speed, whenever that switch opens up, that capacitor will itself be charged. So we have to be a little bit careful about that. Now I think that these capacitors are actually going to self-discharge. There's no like bleed resistor across them. I suppose we could add something like that, although I've not seen that in one of these motors. But So we'll have to be a little bit careful that that capacitor is actually discharged, because otherwise, obviously, you could have a quite considerable voltage, and it could be a lethal charge on there. So as we're not too sure what the voltage is actually likely to be across the capacitor, remember, you're going to have the capacitor, and that's going to have a capacitive reactance, and then you can have the inductor here, the winding, which is going to have an inductive reactance. So they're going to work as a voltage divider. So you're not going to have, I know you're not going to have the full voltage, the full AC voltage across the capacitor. It's going to be split between the capacitor and the inductor, but we're not too sure how much. Okay, so the question is it within this 125 volts, or is it going to exceed that? So let's try this then. So we should be quite safe. We are 450 volts AC maximum on that capacitor, and let's just check that those connections are, it's obviously not particularly safe, but I'm going to keep my hands well away from there. So I'll just throw the switch. Oh, by the way, let's just have a look. In fact, let's just start it and then stop again. Okay. So that's the rotor spinning around. As it slows down, you'll hear that's the centrifugal switch click out, or rather click back in. So now the switch is closed. This time around, what we're going to do, now it started successfully anyway, didn't it? So this time around, we'll look at this analog meter. I've got digital meters, but I think an analog meter is quite nice to see because you can see the needle moving. And I've got it on 600 volt setting. Incidentally, I don't think that these test leads are probably much good at all, and probably not even rated for 600 volts. I'm going to be a little bit careful here. So if you're looking at the 600 volt scale, you're looking at the topmost numbers there. Okay. So let's see how high the needle deflects to. Let's see if we can get it to focus. Sorry, lost focus there for a moment. See what we can do. We've got lights above me as well. Sorry, I'm like sat on the garage floor at the moment trying to do this. And, approximately, I'd say that capacitor charged up to something like about 180 volts. So 180 volts is well within spec for that capacitor. And, it's pushing the 125 volts. A little bit too high, I would say. So the question that you might be thinking about, why has that capacitor still got a charge on it? Well, because we've opened the switch, there's nowhere for the charge to go. It will self-discharge through itself, and ever so slowly through the meter, because of course the meter has very high resistance. But if we stop the motor, then that switch is then going to close, and then so if there is a charge on the capacitor, we should be able to discharge through there. So we should see the needle go down fairly rapidly when we hear that centrifugal switch closed. So let's try that. There we go. Okay, so the capacitor has now discharged itself. So personally, I would say that from that simple test so far, the voltage has gone up a little bit too high for this capacitor. Now, whether this was the originally fitted capacitor, I'm not too sure. It's not hugely high, and there might be some other characteristic of this capacitor which means that the voltage doesn't rise up so high. So I'm just wondering about that. Maybe there's like a series resistance within the capacitor which is going to affect this in some way. I just don't know. I'm not too sure about that. Think about that in a bit more detail. So what I'll do now, I'm just going to do multiple parts on this video. And I'll get this one hooked up. It's probably easier for me to do that off camera because I'm hand holding the phone at the moment. And then I'll record a second video just showing what we find when we've got this one. And I might, if it seems worthwhile, we might even try a lower capacitance motor start capacitor such as this one, which is that's 30 microfarads. Okay, but it's still a higher voltage 450 volts AC rated one. Okay, so I'm going to stop now and switch over the capacitors.